Pause. Okay, so the idea is if I have a set of values that are either we know it's normally distributed or essentially normally distributed. The problem is in real life, things aren't normally distributed automatically. You know, if we were talking about lifespans of some, you know, South African or South American tree frog, we have no idea if they're normally distributed. You know, we'd have to actually study them for years. But there's certain things we absolutely know. Any standardized test score. The term standardized means regardless of what the scores are, when you group them together, you make them normal by scaling them and doing things. So any standardized test, if you ever took, you took your SATs in high school perhaps, or you took an not the AP, but the, what's the other thing besides SATs? The ACTs? The different types of tests you can take in high school because you either want to get college credit or you want to move on. You're taking the GRE.
What's that? What's that test?
The SAT, yeah. The GRE, which is like the SAT for grad school. You take the MCATs, that's for med school. The LSATs, that's for law school. These are always standardized. So it's like I got 50 right. Well, then they give you this score, so it's easier to compare to other scores. Those we know are normally distributed. Okay. There's a lot of things that we know phenomena that are normally distributed. The two I love using are human height, because we do have a lot of humans. You know, we can actually look at it and see a perfect bell shape, and duration of pregnancies. That's one of my favorite ones to study. I became a pregnancy expert on our first. I mean, I read everything and I learned a lot of things. There's a lot of misinformation on pregnancies. But the idea when you have a due date, the idea of the due date, that's not when the baby is due. That's the highest probability of when the baby would be born based on when it's believed you got pregnant. Now, do people know exactly the moment they get pregnant? Usually not. My wife does.
How many children?
Oh gosh, there's X1, X2, Y1, and Y2. It's easier that way. You know, Y1 and Y2 obviously the boys, X1 and X2 are obviously the girls because chromosomes and stuff. Yeah, no, it's yeah. My wife's a math teacher. This, I know it sounds kind of weird. All my children are 37 months apart, and they were all planned usually a couple of years ahead of time. I'd like, let's shoot for honor about this date. Now, that's supposed to be impossible. No, literally, I would say honor around this date and be okay. Let's start trying. Okay, you know, let's start operating. Yeah, my wife, and she was absolutely punctual. The first three were born on their due dates. Now, the thing is, that's not likely to happen. That's like saying I'm going to flip a coin 1,000 times and get exactly 500 tails. Yes, that's the highest probability outcome, but that's not a guarantee. So pregnancies, it's a perfect example. If we look at pregnancies, okay, let's call this on time. In other words, whatever the predicted date is also the highest probability. It turns out pregnancies are really cool. The standard deviation for pregnancies is 7 days. Now, what did we see last day? Most all outcomes happen within 2 standard deviations. So let's say that's 2 weeks. Yes, get what I'm after here? Let's say that's 2 weeks in the other direction. So this would represent 2 weeks early. This would represent 2 weeks late. And when we looked up the numbers last week, you remember we looked up the probability of being between -2 and 2. That was one of the quiz questions. And you said it was around 95%, 0.95. Wow. What does that mean in simple English? Over 95% of all babies born in the world are born within 2 weeks of their due date. Oh, isn't that interesting? And by the way, you're absolutely equally likely to be late as you are to be early. Now remember, the due date is not an absolute science. It's when the doc estimated the most likely probability. Now, do you know how the due date is actually calculated? I became a pregnancy expert, you know, having lots of babies. What they do is they ask a woman, when was her last menstrual cycle? Those are generally 4 weeks between. During a menstrual cycle, the highest probability, believe it or not, of getting pregnant is exactly halfway between. Did you know that? That's when you're at your peak. Closer to cycle is the lowest probability. Exactly halfway in between is the highest probability. So what the doctors always do is say, let's assume you got pregnant on that date. They backdate it 2 weeks to when your last menstrual cycle was, and then they predict a date 40 weeks from that day. Most people believe a pregnancy lasts 40 weeks. No, a pregnancy lasts 38 weeks, first of all. So the 40 weeks is a myth. It's 40 weeks from your last menstrual cycle, not 40 weeks from the day you got pregnant. Did you know that? That's kind of crazy science, but it's actually simple science. Okay, so that's the most likely date, but does that mean that's the day that somebody did get pregnant? No, they could have got pregnant a few days before, a few days after. That's why it's equally likely to be early as it is late. Now, oftentimes during the pregnancy, let's say 2 or 3 months in, they might adjust the due date because of the size of the fetus. They'll say, you know, this fetus is a little bit bigger than somebody who would be due, so maybe we're going to move the due date up a few days. They did that on my firstborn. They changed the original due date, which was actually the day she was born, and moved it up. But the thing was that she was born on her original due date, exactly, which is just crazy. Only my last one was late. So if we look at it this way, then what do we call anybody in this region? No, but actually have a name for somebody born here. They're called a preemie.
Oh.
That's what a preemie is.
Yeah.
Born premature means you were born more than 2 weeks early.
Okay.
C-section. You're really late. You're really late. And yeah, we're going to have to induce. You know why? That head is just getting a little bit too big to go down the canal kind of thing. There's a reason for that they induce here because the baby's getting too big. You know, there's a reason women have babies and not men. I always joke, if God made men to have babies, we would definitely be the last generation on earth because no one would ever do. Yeah, I have no idea how my wife can go through that as many times as she did. They call that, what do they call it? Selective amnesia is actually the term. No, they call that selective amnesia. I'm never doing this again. And she'd say that after each one.
All alone. That's the way I think it. I'm like,
well, anyway, so when we study this, we know from observation that duration of pregnancies are normally distributed with a mean of 38 weeks and a standard deviation of 1 week. What does that mean? That means if you're 1 week late or 1 week early, your z-score is 1. So I want to look at this as a probability question now. If the mean is 38 weeks, don't worry about how many days that is. And the standard deviation is 1 week. Now, this isn't exact. It might be, 7.3. We'll just use 1 week. Makes it easy. Then what we want to do is, what is the probability of being at least 1 week early? Now, a week early is not preemie. It's just a week early. We say preemie when it's more than 2 weeks because now you're outside the logical range. You got pregnant way earlier than we thought. Now, I always kind of laugh at this one, except in rare cases, babies are never early or late. Not a joke. Babies are exactly on time. It was the prediction that was off, not the baby isn't off. The baby's not early, the baby's not late. It was the predicted date that was off. So when you say, oh, my child was a day early or a day late, no, they were exactly when they were supposed to be born. Except except in the cases of it being induced, of course. They're born exactly when they're supposed to be born. It's just the original prediction, which by the way is pretty incredible. You could predict it down to a day. I mean, think about that. The science of saying it's going to be born on this day, 9 months from now. That's really quite amazing. But it was the prediction that was off, not the baby. So we call these the extremes, the outliers. That means something else is going on physically or medically. Okay, so for a baby to be born a few months early, or baby pretty much can't be born a few months late, I'm pretty sure. I don't think I've ever heard anybody pregnant for a year. That would be kind of weird. All right, so what does that mean? That means I am asking. So in my picture, I'm asking for this. Oh, that's easy. I just go to the z-score in the table and look it up because remember the table is always to the left, except I don't have a z-score yet. I don't have a z-score yet. Oh, but if 1 week is the standard deviation and I'm saying 1 week, aren't I asking for a z-score of 1 or -1 here? Does that make sense? So I'm asking you in this problem, what is the probability that z is less than, now, if 1 week is the standard deviation, then 1 week early would be a z-score of -1. 1 week late would be a z-score of positive 1. Does that make sense? Because 1 week early, you're left of the mean. 1 week late, you're to the right of the mean. So I am asking you, and we usually always put two zeros, even though, yeah, I know it's -1, but when I look it up in the table. So when we look this up in the table, okay. Now, everybody here, let's do this. Savina, I'm going to do a share screen. Savina, do you have the table or access to a table?
Yes.
You have the detail, you have this one right here?
I don't have that one, but I could find it.
But you need a Z table. I can show you this one, but you'll need a Z table at some, because that's all we're doing today. So what is the number that you guys see corresponds with a Z score of -1.00? 0.1587. So you just said in simple English, what we usually refer to this as a normal pregnancy, not like normal distribution, normal, like there's no complications. There's nothing, there's no issues. Do issues happen? Yeah, but not that often. So in a normal pregnancy, the probability of being born 1 week or more early is only this. That's not very big, is it? Now, without doing a lot of math, what do you suppose the probability of being at least 1 week late would be? The same number. Beautiful. Does that make sense? Why? Oh, because I'm looking at the same area, just in the other direction. So the probability of being born a week or more early is that number. The probability of being born a week or more late is that number. Interesting. Yeah.
So Professor, say we said the probability of being born 2 weeks early, it would be -2 point.
So now you'd look up exactly. Let's look up -2.0.
Okay.
What's the probability of being born at least 2 weeks early, 2 or more? What is that number? No. Look up a z-score of -2.00.
0.228.
0.228. That's barely over 2%. What does that mean? Only around 2% of babies are born more than 2 weeks early. Again, that's why we would call them preemies, because that's a really, really small percentage. That's about 1 in, so where is it? 228. Let me use my calculator. And so sometimes it helps to convert things. That's about 1 in 44. About 1 out of every 44 babies is born 2 weeks or more early. So it's not like it never happens. It just doesn't happen all that often. Okay. Does that make sense? So here's the beauty. Now, once we know how to read a Z table, we can now talk about situations. And I can ask you now any question about pregnancies. I can say, what's the probability of being born between here and here, after this, before this? So let's try that. And I'm going to show you how to do the actual writing of it. Right now, we have a really good picture, and we have, I made it really easy by using exactly 1 week and all that stuff. But now let's. This is called the normal curve. So there's no rectangles here. And the reason is we do the histograms for discrete data, like how many kids you have, how many units are you taking, how many cars are in your parking lot. But what if I was measuring things like heights, or I'm measuring time? Oh, those are decimals. Those are continuous numbers. Those aren't, you can have 1 minute and you can have 2 minutes, but aren't there an infinite number of times between 1 minute and 2 minutes? I can use decimals. So when it's continuous, we don't use histograms, we use curves. And then I say, what's the area in here? And that's the whole point. If it's a normal distribution, the word normal distribution literally means it's symmetric. Symmetric means visually, it looks like a mirror image on one side and on the other. So it does this. That's what symmetry is. So think of geometric shapes. A square, for example. If I drew a line right down the middle, it would look like a mirror image, wouldn't it?
Mhm.
So we'd say this one has symmetry. But if I took, no, don't have anything in here that's not, the mouse here is just some odd shape. There's no mirror. It doesn't look exactly the same on one side as the other. Rarely do things actually have symmetry. That's an unusual thing. Another way of thinking of normal distribution, the mean is the peak, the median is the peak. Because remember, the median is half the scores are above and half the scores are below. Oh, so if the mean and the median are the same, we really like that. Does that happen in reality? The mean, and the two examples I've used in day one are income and housing costs. Because there's no upper limit to housing costs, a house can be forever and ever. There's no upper limit to income. If we use the mean to describe income, then most people would be below average. Because one Bill Gates makes the mean much bigger than the middle. Does that make sense? One, super, mansion that's, $100 million makes the average housing cost much more than it actually is. And most people would be below the middle. So the median is the middlemost value. So it doesn't matter how far you go that way, it's still the one in the middle where half are above and half are below. That's why in certain situations, whenever the news is reporting data, hey, the average housing cost in San Diego is, they usually will actually say the median housing cost. So if you pay attention, they won't use the word average, they'll use the word median, because when they say average, it's kind of vague. Are they using the mean? I don't know. Does that make sense? So they'll say the median housing cost. So now it doesn't matter how expensive the most expensive one is, it's not going to change where the middle is. And we really want the middle. In a normal distribution, the middle is the numerical average at the same time. Oh, okay. So everything kind of works nice. Plus, it's much easier to do the calculations. When you have a skewed set of data, it's not. So a coin flip, remember when you draw in the rectangles? What did you notice in the coin flip? You had symmetry. It was perfect, right? The rectangles look the same in my probability distribution and my histogram. But if we were doing things like the multiple choice test, it would go like this, because all of the outcomes are at the beginning. No one's going to get everyone right. So in the binomial situation, like the coin flip, you get symmetry if it's a 50-50 situation. Like a coin flip's 50-50, a dice roll is not. So only the coin flip would be, the symmetry. The coin flip would act a lot like this, in other words, and we'll actually use that to our advantage later. So let me ask you a question. Let me go back to the, okay. So here's the question. Given this information, so I'm going to change it slightly. I'm going to change it slightly and go with days rather than weeks. So 38. So the mean for pregnancies is actually 200, I believe it's 266 days. That's 38 weeks. And the standard deviation is 7 days. Because we shouldn't have to measure, early or late in terms of weeks. We usually do it in terms of days, don't we? You were a day early, you were 3 days late, that kind of thing. So now, let's find the probability of a baby being born between 1 day and, let's say, 6 days late. So graphically, what would that look like? Well, if the average is on time, you agree the average should be on time, then I'm kind of asking for maybe like from here to here. Because we'll say to the right is late, to the left is early. That's what we're asking. Does that make sense? So in other words, if 266 days is average, then what am I asking? Between 267 and 272, does that sound right? 1 more and 6 more? So let's say X equals the number of days, then the probability that X is between, now what was 1 day late? 1 day late would be 267. 6 days late would be 272. That's what we're asking. What's the probability that a baby took between 267 and 272 days? Am I going to look up 267 and 272 on my table? Those are Z values on my table. They're Z values between mainly -3 and 3. So what we need to do is calculate the Z values that go with those outcomes. Now, how do I do it? Use these numbers right here. Yeah, Andrew.
The X is just another way.
That's our random variable. That's X would be the length of time it takes for the baby to be born. So your X would be different than my X, it would be different from Rosalind's X. The X is how many days it took you to be born. Not days early or days late, just how many days. If 266 is the average, then you can say, oh, if I'm 1 day early, I was 265 days. If I'm 1 day late, I'm 267 days. So think of it like that.
Professor, do you mind saying what you just wrote, the equation in English? Again?
Yeah.
The
What's the,
probability
that the baby is between, the baby took between 267 and 272 days to be born. This is 38 weeks. So if the average baby is, the average is 266 days.
I'm sorry.
The average duration of a pregnancy is 266 days.
Yes.
So what's the probability that the baby took between 267, 1 day late, and 272, 6 days late? Because that was the question in terms of days late or days early. So now I can't look up those numbers in my tables, can I? What is the Z-score again? The Z-score is the score minus the mean. In this case, the score would be the number of days, obviously, over the standard deviation. So I have two Z values I have to calculate. I have to calculate the Z value that goes with this guy. By the way, this statement here is that's just a shorter way of saying the question. In words, the question is, what is the probability that the duration of time the baby was in the belly was between 267 and 272 days? So you say, X is between 267 and 272.
Okay.
This is a faster way of saying the same thing. But I need Z's. See, I need something that looks like this, don't I? Because then I can look up the numbers in my table.
But I was just thinking you used X as a Z.
No. X is the actual outcome. I have to make a Z. Last day, remember, I just gave you the Z's and we looked them up, but we didn't have any problems to go with it. We didn't have any way, where are the Z's coming from? I was just making them up. Oh,
So
okay.
we're trying to find X.
Well, no, this is what we're told.
Okay.
So how do you calculate Z? Let's start with this guy. The Z score for 267 is what? 267 minus 266 divided by 7. Okay, score minus mean over sigma. By the way, in every situation, you have to know the mean and standard deviation. It's an impossible question if I don't know both of those. Does that make sense? Now, once I know the mean and standard deviation, you can ask me any question you want because I'm going to use those over and over again. So would you agree this is exactly 1/7? Now, as a decimal, I need 1/7 as a decimal because I have to look up decimals in my table. So what would the decimal be for 1/7? 0.14. And the reason you're stopping at 2 is my table only has 2 decimals for Z. Everybody understand that? You can give me as many as you want, but if you look at your table, the Z values are only 2 decimal places. So you only need to go 2. Okay? What is the second Z value? It's 272 minus 266 over 7. Or if you want 6/7. Now I need to put that in the calculator. Give me a decimal value for 6/7 that's 2 places only. So 2 places, it would be 0.86. So the question of what's the probability that a baby is born between 267 and 272 days is exactly the same question as what's the probability that Z is between 0.14 and 0.86. But this is what we spent all last class doing, looking up this question. This question I don't calculate, I just read. Now, do you remember how we did it? Let me draw it. Let's see. How we did this one, I'll do it here. Remember what we did? We looked up the bigger Z, and then we subtracted the smaller Z, and that gave us the area between. Do you remember how to do that? So what are we going to do? We're going to say, I want the probability that Z is less than 0.86, and I'm going to subtract the probability that it's less than 0.14. Again, big area minus little area gives me between area. That's always true. So get your table out. All right, what is the Z value? All right, so then I'm going to give you back the share screen so you can look it up too. And now we'll need positive Z values. All right. So what is the probability that Z is smaller than 0.86? So go to your table. By the way, make sure you're on the, there's two tables, right? The positives and the negatives. We want to be on the positive side now. So make sure you're looking at the positives. Yeah, it'll be easier to find it if you have a, right. Why are there 2 pages? Because there's too many values to put on one.
Right.
Yeah, it's, if you guys need calculators, I have extra calculators too. I do want them back though. So everybody, what is the probability that I am less than 0.86 in the Z values? 0.8051. And now I'm subtracting the second probability because I want the area between. So what's the probability I'm less than 0.14? 5557. Hopefully we're all seeing the exact same thing because we're all using the exact same table. We probably should all get the same answer. So do it in your head, use your calculator, doesn't matter. What do I get when I subtract? I get 0.2494. Okay, what does that mean? Explain to me in English, because by the way, statistics is a mathematics, but it's one of the very few mathematics that you apply to everyday life all the time. And I've taught stats a million times. And I always joke with my students, I'll say, do not give me lawyers speak.
There's a measurable probability that the success rate of the following outcomes follow the following.
What? What did we just say? We just said the probability of a baby being born between 1 and 6 days late, about 25% of the time. In English, about 25% of the time, babies are born between 1 and 6 days late. Does that make sense? That's what we just calculated. I would much rather you give me an answer like that because that's how you talk to people. You don't need to be mathy, but you have to have the right, the right numbers. Otherwise, you'd be saying something that's incorrect. We just calculated. We found a betweener. Do you agree that this shouldn't be a huge probability? It's a betweener, and this is the probability. But the beautiful thing about this is you didn't have to do calculations. You were using calculations that the computer generated. You just have to know which ones you're going to look up. And the only calculating you did was the Z-score. Woo. Now, the difference in what we did last day I said, here's how you look up a Z-score and a probability in a table. And I just gave you a bunch of Z-scores and greater thans and less thans, and you looked them up. Great. I don't know where I would ever actually use this in real life. Today, we're using this in real life. So now we have a situation. I ask a question, you say, okay, you asked me a question, meaningful numbers. I need to calculate the Z value, which is one of the easier calculations we will ever have. And then that's the number I'm going to look up because we can't look up 272 days. That's not going to show up in a table. We have to look up the Z value that goes with 272 days. Now, yeah.
So the Z-score equals, I'm looking at that calculation over there. Is that the formula?
Yeah, that's the formula. It's always score minus mean over standard deviation, where those have to be given.
Okay.
You have to know those. If I asked you a question and I said, what's the probability? And you said, but you never told me what the mean or the standard deviation is, then it's an impossible question. There's no numbers to put in.
Right.
The X is the individual outcome we're looking at. We looked at 1 day late, 6 days late, 3 days early, a week early. But these numbers are forevermore. These are the numbers the universe, planet Earth uses. I don't know about universe. No. I mean, there will be problems later on that you might have to calculate the mean based on the given information. Let's say I gave you a whole bunch, we've done this before. I gave you like 50, the Brown family reunion problem. I gave you 50 ages. You calculated the mean for me in that problem. So now if I said, okay, Brown family ages are normally distributed, you'd calculate the mean, you'd calculate the standard deviation. That's a lot more work. And in real life, you would probably use a computer to do both. I'm not interested in doing that calculation here. It just takes too long because you're doing it by hand in a calculator. In real life, people would use a computer and they'd enter thousands of numbers, millions of numbers. My closest friend's a statistician. He works for the University of Colorado, Denver, and he handles, and I told you about this before, but he handles data sets that are huge. He used to work for a company that also worked for the DoD, and never did he work with less than 10,000 numbers at a time. Well, he doesn't have a handheld calculator. He has a computer that he downloads the data sets. He doesn't enter them by hand. That would take a long time and be very inefficient. But he knows how the calculations are all done. And so when he's doing stuff like this, he understands how the calculation is done so he can read the information that the computer's spitting out. We're doing short, simple stuff that we can do by hand. You understand? We have a cheap calculator. We can do this by hand. That's all that matters. Okay. Now let's do something slightly different. I want to now look up a probability and work backwards and see if we can figure out how many days. So here's the question I have. Is there a number of days? Remember, if 266 is the average, is there a number of days that, let's say, 90% of all babies are born with, you know, by a certain number of days? Maybe it's 275 days, maybe it's 280. Remember, at 266, exactly half of all babies are born by 266. A little more than half the baby, as the number of days increase, there'd be more than half the babies. Agreed? I would like to know, is there a place? The answer is yes. But I want to know, let's say I'm going to put the 266. I want to know 90% of all the babies are born by what day? Is that a reasonable question? 90% of all babies are born by what day? I don't know what the number is, but is that a reasonable question?
Yes.
Yeah, I should be able to look it up. So what we're going to do is go to the table and find the probability in the table that is the closest. What's 90%? Would that be 0.9? So everybody go to your table and look up the probability. So if you look in the bottom right corner of your positives, all of those are 0.9s, right? 0.9999. Find the one that's the closest to 0.9000. You're not going to have it exactly. What number is the closest to 0.9 on your table? Does anybody see it? I see one 0.8997. Do you guys see that number? Look at the probabilities, not the z-scores.
Oh,
Does everyone see 0.8997? Of all of the numbers in my table, that is the one that's the closest to 0.9. I mean, 8997. That's pretty darn close to 0.9. Okay, does everybody agree with that?
yes.
Now, what z-score goes with that number? 1 point, keep going.
1.208.
1.28.
1.28.
Okay, does everybody catch that? The z-score, by the way, this is not something you memorize. It's something you don't, by the way, next week, we're gonna have a quiz on the z-table. I want you to memorize all the probabilities. Okay, that would be terrifying if a human being could memorize like 2 or 3 of them. But yeah, no, you don't, there's thousands. Don't, you look them up, you don't memorize them. That would be utter insanity. So we just did this. Now, if this is 266, the z-score you just said was 1.28. You all agree? That's the z-score. That doesn't tell me how many days it is, but I should be able to work backwards rather simply. See, go back to this. I've told you the mean, I've told you the sigma, and now we have the z. What we don't know is the x. Can we solve for the x? Yeah. Simple algebra. Multiply both sides by sigma, and then would I have sigma z equals x minus mu, right? If I multiply by sigma, and now add mu to the other side, and so x would equal sigma z plus mu. If I want to get the x by itself, I'd multiply by sigma, I'd add mu. But I know mu, sigma, and z. By the way, this is the other thing we can always do. We can predict. So I want to plan my vacation next summer. My wife's pregnant. No, not really, but you know, I wish. Okay, I want to plan my vacation next summer. My wife's pregnant and her due date is whatever. Now, our vacation falls, You know, sometime, well, I want to be 90% certain that the baby's going to be born before we go on vacation. Does that sound like a valid question?
Yes.
So therefore, what is the number of days where 90% of all babies are going to be born by? Well, it's right here. It's going to be what? 7. What was my Z? 1.28.
Yeah.
My mu, 266. Let's do that calculation. 7 times 1.28 plus 266. It's okay to round. It's about what? Whoops, 274.96, so about 275 days. What did we just say in simple English? 90% of all babies are born within 275 days. Is that useful information perhaps?
Yes.
For hospitals, for planning, for the doctor? Yeah. So only 10% of babies therefore would be born in more than 275 days. Oh, okay. Now, were any of you really big babies? I have this feeling that maybe Robert was a big baby. I don't know. I had this thought. Do you know how much you weighed?
Like 10 pounds.
So were you late? Or did mom have to have a C-section? Because 10 is really big. Do you know?
I was late.
You're a 10-pound baby?
See, the thing is, when a baby's that heavy, it's usually because the baby's late, because the baby has time to keep growing and growing and growing. When a baby's really early, they tend to be smaller. You know, my kids, for my wife's sake, my kids were all, I think my smallest was 6'11" and my biggest was 7'11". That's not big, that's average, you know, 7.5 to 8 is about average. Mine were all, you know, in a very, I'd say, comfortable range. But I have a friend who had a baby, and he's, the young man is probably 6'2", 150, 160 pounds. He was 12 pounds at birth, 32 pounds at a year. He couldn't hold his head up until he was 2 years old.
Ooh.
He was the largest baby anybody had ever seen, yet by the time he was in high school, he was just a tall, skinny kid. He never was heavy, but he was a gigantic. I don't even think you were 30 pounds at 30 pounds at a year old. None of my children, by the way, were 30 pounds at 3 years old. This kid was 32 pounds at a year. That just, I don't know what they were feeding him. I think they were feeding him the stuff that you give cows to make the cows bigger, you know, something. His baby was, they thought this kid was going to be, you know, 8 feet tall, 1,000 pounds. And turns out he thinned out, he stopped growing, and he was the biggest kid for a while. And after a while, he was just above average height, but he was never big after that. He was actually always kind of skinny. Just the irony. So we've just done some really incredibly cool calculations, if you think about it. Based on the fact that we know the mean and standard deviation, you could ask me any question about the duration of pregnancy. What's the probability of being born more than this many days, less than this many days, between this many days? What percentage of babies are born in this range? We can do this. Does that seem cool that we can do this once we have the information? And again, the idea is it's normally distributed. Now we're going to change into a different example. This one might even be more familiar to you. I like using this one because, again, this is absolute information that we already know. All right. Does everybody know what an IQ stands for and what it means? You hear things like, oh, somebody's high IQ.
Quartile.
That's something. No, that's the box plot. Intelligence quotient.
That makes sense.
To be honest, I don't know what the quotient part of intelligence quotient is. IQ, there's a common misconception. IQ is not a measure of how smart you are. It's a measure of what do you think? What do you think it is?
How well your brain functions.
That's probably a better way of describing what it is.
That's actually like a formula, so it's like your mental age over your actual age.
It's an easier way of thinking about it. If you got your IQ measured at 4 and you got your IQ measured at 40, would you say you're probably a little smarter at 40? I would hope.
Yes.
Your IQ is exactly the same. IQ is not what you know, it's really what you're capable of knowing. That's that's probably a better way of thinking about it. What is your brain capacity for understanding? So a high IQ person isn't necessarily smart. Their brain can just take on more and absorb more. I've known people who are unbelievably successful, but very average in terms of that aspect. And I've had students who were off the charts with the IQ, but they couldn't even function in a classroom situation.
Yeah.
So it doesn't mean how smart you are, but most people have their IQ measured at some point in their life, usually as children, especially if you have kids who are kind of odd, off the spectrum kind of kids. I was measured at a young age and I terrified people. You know, I was one of those my parents didn't know what to do with. I could tell you horror stories. I'd rather not because it brings up painful memories, but you might find this hard to believe, but I didn't talk until I was, I don't know, 5, 6 years old. Well, I spoke, but it wasn't a language any human could understand.
Wow.
I had a very serious speech impediment.
Oh, wow.
And I had to go through training for years.
Wow.
So I was already kind of an outcast, but they measured my IQ and you don't tell a 4-year-old, but they measured my IQ and it was higher than they'd ever seen.
Wow.
At first grade, when they actually do the standardized testing, I was testing graduate level mathematics. In first grade, I hadn't been taught anything yet. They couldn't explain it. I was in trouble all the time. I spent more time in the principal's office than I did in the classroom. That's not a joke, because I was always in trouble. They didn't know how to rein me in, and back then they didn't have anything. So I just, when I was really little, I got beat up a lot because I was really small.
Not now.
No, I was, it was odd growing up.
Yeah.
You'd laugh if you knew what I sounded like. My older relatives for years always teased me. They'd have fun. That's what it's called, a tongue thrust. Donald Duck. And apparently the worst thing you could possibly be was a stupid icky butt face. That's when I was really upset. You were a stupid icky butt face. That was my go-to insult. But it was, so all of my relatives for most of my life would, whenever they'd see me, they'd call me stupid, and then they'd just laugh hysterically because by that time I had overcome it. By the time I was in high school, I was pretty much, normal. But it was a strange upbringing. But I use IQ as an example because it's a very controversial thing, because it almost feels like it's an opinion thing. Have any of you taken an online IQ test? You get all the time log on and take the IQ test, and I guarantee you probably score off the charts. Anybody does the online one always scores unbelievably high. No, okay, I every time I hear someone say, I did the online one and I scored unbelievably high, but it's based on what? It's not a professional doing it, and probably the underlying thing is they want to sell you something, and I don't know. I'm always suspicious of those things. Yeah.
Well, I took a more official one, and like all they asked for was my
No credit card information. So I want to use IQ now because IQ, most people can relate to because they've heard of it. So with IQ, like the SATs and things like that, these are standardized scores. So the scores are made to fit neatly into a box. So it's not the number you get, it's now standardized. So for IQ, the mean is exactly 100. The standard deviation is exactly 15. Therefore, if you were 2 standard deviations above the mean, what would your IQ be? 130. If you were above 130, we would call you high IQ. What is 2 standard deviations below the mean? Do you know what you're called if you're below 70? Mentally retarded. That is the formal legal definition of mental retardation, under 70.
Oh, wow.
No, mentally retarded means your brain is not fully developed, kind of thing. You guys remember Forrest Gump? What was his IQ?
Right, Forrest, right.
Do you remember his IQ, I think, was 75. So he was barely above that. But you remember Forrest wasn't the sharpest tool in the shed, and his mama had to pull strings to get him into public school and all that because he was a low IQ. Now, I don't think that was based on a true story, but But if you guys remember Forrest Gump, yeah, he was kind of dopey. But 70. Now, has anyone ever heard of the organization called Mensa?
Yeah.
Do you know what Mensa is?
It's like for really highly intelligent individuals.
It's for high IQs. It's for the top, I believe it's the top 2%.
Is that your class?
Yeah.
They make the Megamind people, is that those?
The Megamind people, yeah. But Mensa is an organization of high IQ. Now, does it mean they're smart? Well, probably they're smart. I mean, hopefully they're people that did something. Nothing to me is more wasteful than when somebody has a certain talent. Doesn't matter what it is. You have a musical talent, but you won't play an instrument. You have a great singing voice, but you won't sing. You're really, really fast, but you don't want to do any form of sports. You're really, really smart, but you're okay, working at the gas station. Like, use that talent, God gave you this talent, use it. But the Mensa folk generally are the people that are the high IQ and probably somewhat successful because, well, it's very ego driven. They want people to know that they are in that group. Mensa, I believe, is the top 2%. So let's have some fun and let's figure out what IQ would put you in Mensa. Now, to be the top 2%, these are the Mensa folks. To be the top 2% means you're higher than what? Good. Okay, everybody got that? This is not, you don't have to be clever. If you're in the top 2%, oh, by the way, wouldn't that make you the 98th percentile? Because remember what that word means? 98th percentile means you're above 98% of the people. Oh, okay. So let's figure out exactly what IQ would qualify you for Mensa, and obviously anything higher than that. So how do I find that? Let's go to our table and let's look up the probability that is the closest to 0.98, because we want to be above 98%. So go to the positive Z's and just start scanning it. What do you see? Anybody see anything here?
979.
You see 9798 and you see 9803. Those are both really, really close. We could really use either one of them. Okay.
Like if you were in that situation, we can.
Oh, what you'd actually do is you on a computer, it would calculate a Z-score that had 3 decimals. See, our Z-scores all have 2. That's out of convenience. So the computer, do you agree? Let's look at the Z-scores for those 2 numbers you just said. You said, so I got to find it again.
0.98, right?
You said 0. So I want the closest to 098. So do you agree that 9798 corresponds with a Z-score of 2.05? And then the next probability of 9803 corresponds with a Z-score of 2.06. Can you all see that? So the Z-score would be somewhere between 205 and 206. It'd probably be like 2.055. That's what you would actually do. So let's say, let's use that number, okay? The Z-score is this. Now, if that's the standard deviation and that's the mean, can you tell me what IQ that would give us? Yeah, let's do like we did before. So all I got to do is take 100, add it to 15 multiplied by 2.055. And what does that give you?
What'd you get? Oh, I see.
What does that give you? 100 plus 15 times 2.055. What number do you get? About, you got 130.8 something, so about 131. Guess what you have to score on your IQ to be invited to join Mensa? Anything 131 or higher.
Where'd you get the 2.004?
We looked it up. Remember, we said we were between 205 and 206. So I just took halfway between them.
Is it really?
Yeah, so you looked up. Those are the numbers that are closest to 0.98.
Oh, I see.
So then I looked at the Z-score that corresponded with this between these. Does everyone find these values? Because they're not calculating, you're just looking them up.
Yes.
Now, isn't that an interesting thing? So if someone says they're in Mensa and they're telling the truth, that means they have an IQ of at least 131. I've heard you know, they'll talk about some kid in some foreign country who's measured at 170 or 180, you know, you hear things like this. I don't know that that's actually possible. I thought because of the way it's measured, I could be wrong, but I don't believe it's actually possible to get above like 160. I don't think there's a measurement that takes you higher. But I had a student a few years back, you'll love this. He had no problem telling everybody in the class that he was the smartest person anybody would have ever met in their lifetimes. Very, very arrogant. I think he might have got a C though in the class. He wasn't very good, but he told us on multiple occasions that he had an IQ of over 200, which really I thought was funny because I'm pretty sure no human being in history of IQ has ever measured 200 or even, there is no way to measure that. That would be awesome. I don't think it's possible. Yeah, because if you think of it this way, you're about 7 standard deviations above the mean, and that's actually not mathematically possible. But he would tell everybody this on a regular basis, which was just, it was so annoying. You don't tell everyone, by the way, I'm so much smarter than you that you should feel privileged to be within 20 feet of me in the classroom. It was that arrogant. And he was very average as a student. I think he barely got a C.
That you made that he looked really pretty on his report card.
He just, well, this is at Mesa College. This is a college. This is probably an 18, 19-year-old. But to announce to the class, by the way, just so you guys know, you know, but then when he couldn't answer simple questions, you're like, well, if you're as smart as you're telling us all, why are you struggling? You know, the lower level folks that are sitting around you who are exceeding mightily. I just thought that was very funny. So IQ is a standardized score. In other words, when you take an IQ test, you don't score 100 or 110. You get a score, and then the score is converted. When you take your SATs, they take the number of right answers you get, and then they convert it to something. We're going to talk about that one also, because that's a really common one that we're very aware of. So here's my question to you. Keep it real simple. Okay. Let's find the probability an individual has an IQ between, I'll keep this relatively simple. Let's say between 94 and 109. So I have the entire population of people. What's the probability an individual's IQ is between 94 and 109? Now, 94 is below average, agreed? 109 is above average. So if I drew a picture, and by the way, I'm a big picture guy. I always draw a picture because it makes it easier for me to conceptualize what I'm about to answer.
Helpful, I think.
Say again?
I'm very helpful.
So if the mean is 100, 94 would be to the left of the mean, 109 to be to the right of the mean. So I'm asking for this. I don't have a number in mind. I don't have any idea what the probability is, but that's what I'm looking for. I cannot look up 94 and 109. So I'm asking if we always use X, just as can be. X is our random variable. X represents the outcome we're looking for. So X is between 94 and 109. So just like before, what I need to do is convert that to something that looks like this. Because I can't look up the 104 or the 94, but I can look up the Z-score that goes with 94. Does that make sense? Now, I don't know what the Z-score is, but it's certainly going to be simple to calculate because I have the mean is 100. I have sigma is 15. So calculating the Z-score for each of these will be absolutely trivial. I mean, easy enough that you technically probably don't even need a calculator, but use a calculator anyway. Okay. So off to the side, let's do our calculations. For the X value of 94, Z equals 94 minus 100 over 15. Right? Score minus mean divided by standard deviation. What is that number exactly? It's 0.4? So what am I going to look up? I need the 0. Why do I need the 0? Because in the 0.4 row, there's actually 10 numbers. Oh, I need 0.40 as opposed to 0.41 or 0.42 or 0.43. Does everybody agree with that? Now, it might seem redundant to put the 0, but I gotta go to the exact right place. What's the z-score for a score of 109? Well, z is 109 minus 100 over 15, and what would that be? So the first one's, by the way, why is the first one negative? In English, why is the first z-score negative?
It's under the.
Because 94 is below average. Huh. A negative z-score means you are below average, because when you subtracted the average, you got a negative value. That's what it means to be below average. People think of that as being a put down. It's nothing to the put down, it's the mathematics. If you take a value that's below average, your z-score has to be negative because you're subtracting a bigger number. So what's the second z-score?
102.3. That's what I-
Not very close.
0.6.
0.6. You're not using your parentheses. Total numerator, Robert. Yeah.
Yeah.
109 minus 100 is 9, so your answer is 915, so 0.6. Now, what does that mean? Go over to here. Negative 0.4, 0.6. These are the numbers I'm going to look up in my table. Okay, is everybody cool?
Mhm.
Now, what am I going to do? I'm going to take the bigger one and subtract the lower one. Don't add them. If you add them, you might get a probability that's bigger than 1. And we know that would not be a good idea, right? If probability of 1 is absolute certainty, what would a probability bigger than 1 be? Really certain? No, really impossible. So this is the probability z is less than 0.60. That's the bigger one. Remember, that's that one. And then what am I going to do? Minus the probability that z is smaller than negative 40, because that's what that one would be. And that gives me the area between. So I need to correctly look these up. One thing you do know as an absolute, if your z-score is negative, the probability of being below it has to be smaller than 0.5. But if your z-score is positive, then the probability of being less than it has to be more than 0.5. Does that make sense? If you take somebody above average and say, what's the probability of somebody's below that score? Well, if they're above average, that means way more than half the people are below them. If you take somebody who's below average and say, what's the probability of being below that score? It's got to be less than half. The reason I'm pointing that out is when we're looking up the numbers, sometimes that's kind of a common sense check. Going, wait a minute. Shouldn't I be getting something smaller? Well, you know why we make a mistake? You never figure this one out. Negative, positive. Do we sometimes look in the wrong table? Yeah, that's why I'm pointing that out. Oh, so the first one, I got to look in the negative table. So everyone find negative 0.4 on the Z. I'm sorry. Let's start with the big one. My bad. Start with the 0.6 and the Z, and what do you find? 0.7257. And now I'm going to subtract. And what's the z-score, or the probability that corresponds with the z-score of negative 0.40? 3446. And what does that give us as an answer? Nice. Calculator brain.
I'm
Or a
telling
calculator in your hand, one or the other. What now? So what do we say in simple English? Around 38% of all human beings have an IQ between 94 and 109. I want to make sense of everything we say today. I want it to make sense in English. You're doing the math. By the way, is the math complicated? I mean, the only calculations, you did this, that's not really calculation. I have to calculate, but I wouldn't call that high level stuff. But I got to get the Z. These are generally referred to as the raw scores. That sounds kind of funny, but if I give you a number, that doesn't tell me what the Z is. The Z is the number of standard deviations above or below the mean that a score is. But it's only the Z that I can look up in the table. And so I used this analogy before and said, so somebody, Robert comes up to me and says, Mr. Brown, I got 80 on the test. Is that good or bad? Oh, you go, well, the test was worth 83 points. Oh, that's really good. Test was worth 1,000 points. Oh, that's really bad. In other words, that 80 is the raw score. Does that tell me anything yet? No. So he says, I got 80, maybe it was 80 out of 100. Okay, is that good? Well, the class average was only 70. Okay, you're a little above average, but the class standard deviation was really small. So I was 3 standard deviations above the mean, which means I was head and shoulders above the class. If all the things you told me, just say, Mr. Brown, on my test the other day, I got a Z-score of 1.5. Whoa, you must have been right at the top of the class. But we don't speak that way, I know, but if you told me your Z-score, see, I'm having fun. He told me the score, but now I'm asking a series of questions because first, out of how many? How'd the rest of the class do? What was the spread of the class? I don't know if your score is good or not until you tell me everything else. But if he told me your Z-score at the combine today, I was trying out for the NFL, my Z-score on the bench press was positive 1.6. That means you probably did more than anybody else there. Believe it or not, that's actually what people do. When you're doing a college app, you're going to transfer, you are all ranked. And everybody has a Z-score calculated. And what they'll do is, just to make it easy, they'll say, okay, we only want to take the top 10% or the top 20% and consider them. So then they go to the table and look up, like we just did, figure out the Z-score. Let's say I want the top 10%. We said the Z-score was 1.28. So they'll say we're only going to look at people that had a Z-score at least 1.28. And then everyone else is weeded out. Now we'll look at those applicants. By the way, do they do this for jobs? Yes. This is police department? Yes. Fire department? Yes. They do this. Why? I had a friend who applied for the fire department. Felt like almost every year. It was really hard to get into years ago. And he said, they give you a test, like an intelligence test, and answer questions. He says, it's not easy. And I said, did any of them have to do with firefighting? There's nothing to do with firefighting. They were using that to weed out the applicants. And then what they did was they took like the top 10%, and now they gave those people an interview. This is done in real life, all over the place, all the time. We don't always know that because we're not the ones applying for that job. But if you think about it this way, I have a job, I have 10 openings, I have 20 openings, but I have thousands of applicants. And that's a lot of work to try to screen everybody. But I don't want to hire the best 20 out of 1,000 applicants. What I maybe want to do is whittle it down to a pool of 50 or 100 people. Now I can select from that group. Does that make sense? That it's just easier to work with if I can have a smaller group. So a lot of times you will take some sort of placement test before you actually do the thing. So there'll be, has anyone ever here had a second interview for a job? What was the point of the first interview?
Right?
To weed out
Yep.
everybody, to say, if you got a second interview, they're saying, okay, you were a worthwhile candidate. If you
Yes.
didn't get a second interview, they're saying you're out. Not that you were somehow a bad person or scum. They're saying you were in their top 10%. That's an easy way to think about it. All of that is based on Z-scores, believe it or not. We don't even realize how much this affects everyday real life. And I'll use the combine for an example. I'm a big football fan. Combine right now is the NFL's meat market. I mean, their series of weeding out candidates at every position. They're giving people numbers. How many reps of 225 pounds did you go on bench? How high was your vertical leap? How far was your standing jump? How fast did you run a 10-yard shuttle back and forth? What did you score on the Wonderlic test? Although they've removed it this year finally. That was their idiotic IQ test. I've seen the Wonderlic test. It's painful. If you have 3 apples and you add 4 apples to the pile, how many apples will you have? Those are the kind of questions they would ask, and people would not miss them. Like, that really matters, though.
So I have a question about like the online degree stuff. It says that there's like an acceptance rate of like, let's just say, for example, like UCSD has an acceptance rate of like 30%. However, your probability is not always 30%, depending on like how long you do in high school. For example, is that dependent on the Z-score?
No, that 30% is 30%. By the way, that's kind of a deceiving. You know, I did poorly in high school. I applied to UCSD. I don't have a 30% probability of getting in. It's 30% of people who are eligible to apply. They have a minimum GPA, minimum SATs. If you don't meet those, your application goes in the round file. It doesn't get counted. You understand that there are minimum scores you have to get. Then you've got the minimum. You've achieved at least the minimum. Now of the people that are eligible to apply, they're saying, we accept 30%, but which 30% are they accepting? Probably mostly the top 30%. But does that change every year? Yes, I'll give you an example. My daughter at a high school applied to UCSD, UCLA, Berkeley, UW, University of Michigan, my map, and a few other East Coast schools. Stanford, she got accepted to everywhere, offered all sorts of loans, no scholarship money. Stanford wrote her a letter saying, we'd like you to apply again next year, blah, 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 blah. What that meant, you usually don't get a letter like that. What it meant was you were a qualified applicant. This year, there were too many. And they actually said last year you would have got in. Probably next year you would get in, but you didn't get in this year because our applicant pool was a little higher than usual. She ended up saying, I'm going to UCSD, or excuse me, Mesa for 2 years, was about to go to UCSD, has already been accepted. They decided to go there. We were went to a trip up to Portland, one of our satellite schools up in Portland, they were awarding a black belt. So I went to represent San Diego, and my oldest kids, who are also black belts, went, and my daughter fell in love with Portland. So decided that day she wanted to go to college in Portland, having never seen any of the schools. So she graduated from the University of Portland, finished grad school at Portland State, has lived there for almost 7 years. Yeah, it's really funny. But the point being that the applications, she applied to University of Portland, she was accepted before she finished her application because her application was off the charts. Remember, she's good enough to get into Stanford. She was good enough to get into, basically, she was actually good enough to get into the Naval Academy. She decided not to do that one. By the way, the hardest school to get into in the United States is not Harvard. It's not Yale. It's not Stanford. It's the Naval Academy. Because their standards are exactly the same, but you have to have the congressional recommendation. Did you know that? To get in the Naval Academy, you not only have to be off the chart smart, you have to actually have a letter from a congresswoman or congressman. And by the way, I don't know anybody who knows a congressman, so therefore that one's a tough one. Yeah.
Yeah, for those schools, but that's not like the average, like regardless of like what type of environment you're gonna go into, it's still gonna be treated the same way. Like,
Yeah, the question though, this is really a good question. We're gonna take a break in a moment. It's a good question because you're saying, how do schools decide? Because a school has a reputation to maintain. That if they're a school known for their excellence of their academic programs, they want to stay excellent. But what if this year's applicant pool isn't as strong as other years? Will there be people getting in this year that might not have gotten in previous years? Of course, because they need to fill those seats. That's still number one.
They're in a bunch of trouble right now, these universities. I saw on the news.
A lot of universities are in trouble. People, during the pandemic, people have kind of not been going to school. Schools have become less important, and those who,
I mean, as far as the admissions, accepting students who don't qualify because their parents have.
well, that's always
I just saw that.
that's always a thing. That wasn't that a big controvery scandal a couple of years ago?
Yeah.
Hollywood folks were getting their
Yeah.
kids in the universities
Yeah.
illegally, and yeah, that just
They just paid
that just
the money, that's
reeks.
it.
That just reeks. And you know, the irony is, as an educator, you get your kid into Stanford, let's say,
Uh-huh.
and the kid did not qualify. Well, you know what? The kid's going to fail out of Stanford because they're not. And so all you're doing is they're wrecked. They're going to fail out of this school they shouldn't have been in the first place. So what was the point of sending them to something out of their own league? That's kind of crazy. All right, let's take a short break. We can come back. We're going to do a little more of this, and I want to go over, obviously. All right, let's rein it back in, folks. Okay, we're going to now do some similar problems to what we just got done doing. All righty, so, gee, this should look kind of familiar. First questions are some IQ questions.
12,
13.
13?
This is for today's study.
On the exam that coming, like not coming up, like next.
Tuesday's exam,
The exam that has this,
exam 3.
are we gonna be able to use this?
No, I need you to memorize the entire tip. Or you can just write it on the back of your hand.
Yeah.
I'm not aggressive. Yeah, let's do that.
Yeah, that's very silly. No. The only alternative, by the way, what most people do is like StatCrunch or R or Stat, they use some powerful software, but then you have to learn how to use the software.
Yeah.
And for a lot of folks, you're like, but I'm only doing it one time and the learning takes some time. By the way, there's nothing wrong with that. That's actually, it's wonderful because you can do it at home, but that's like a separate course.
It is.
When I did stats at San Diego State. I did mathematics at UCSD. I did stats at San Diego State. And you know, it's funny. Nobody in the graduate courses, nobody uses computers, barely calculators, because it's a lot of theory. And when they would do problems, they do small problems. So you could quickly do it by hand if you had to, so you would understand the big picture. There was a 1-unit SAS. SAS is statistical analytical software. It's the most powerful statistics software in the world that's used. My friend, who's the statistician, that's the only software he ever uses. There was a 1-unit SAS course that everybody was encouraged to take. So then when they were taking classes where you actually had to do calculations, you had this under your belt before you took the class. So we're doing courses like linear regression, it's called, where you're looking at thousands of things at one time. Well, you're not going to do that by hand or with a calculator. You understand how to read the results. You don't calculate the results, the computer calculates it. You read them. So here's a problem we just did. All right. So with that information, we just did all of these. I would suggest start by making yourself the little picture. So, okay, 100's in the middle. I want less than 85 on the first one. So that's probably small, isn't it? And the second one is between 100 and 125. The third one, what is range rule of thumb in English? Most outcomes are between, within 2 standard deviations of the mean, so plus or minus 2. So in this case, the range rule of thumb is what outcomes? You just turned in a quiz where you gave me a range rule of thumb answer, didn't you?
I think so.
Yeah, I hope so. Because that was one of the questions. The question on the quiz, it was, what was it? It was the dice. Well, actually, there were 2 range rule of thumbs. One was the rolling of the die. The other was the flipping of the coin, saying range rule of thumb says with this many trials, most outcomes should fall in this range. Now, that's a simple calculation, but it's a really simple way to say what is reasonable, not what's possible.
Reasonable.
What is reasonable? You know, if I went out onto an NBA court tonight against, another team, is it possible mathematically that I could score a basket?
Yes.
Yeah. Is it likely? No. See the difference? It's possible, but not very likely. It's possible you can do something like that today, but not very likely. So we want to know what is a reasonable range, not what's possible. What's possible is actually anything. But what's reasonable? So try these. This is exactly what we just got done doing, obviously. So I'm giving you the raw scores and you have to convert them to z-scores in order to ask the question. But there's not just that. Less than, between. So I have to have the inequalities correct. Because if I have the inequality incorrect, I will be looking at the other half of the table. In other words, whatever my number is, if my number is 0.2, if I'm looking at the inequality correctly, it probably was supposed to be 0.8, the rest of the way. You can't hit negative, you can't exceed 1, you know that. So did we lose Savina? Let me see, hold on a second.
No.
Oh, Manuel was there, I didn't know that. But we never got Destiny today. Huh. Yes. No, hold on, just wanted to see who was here.
Yeah, she was gonna be in the hospital, remember?
Yeah, she was going to try to, well, what I understood, she was going to try to Zoom. Knowing Destiny, she'll be, under the knife surgery and say, yeah, but I got to do math. So that woman is tough. That was, it's a little on the insane side, yes. The woman is definitely insane. Okay, this is taking forever. Hold on. This is not letting me move up here.
I don't know where to start.
And that's what I was gonna ask you. So the U is 100, mean is 100,
Mhm.
the standard deviation is 15.
So then
So
the
I- did I get
the
that
outcome is
correct?
85. So what are we asking for in the first question? We're asking for what's the probability that my outcome is less than 85? And what I need to do is change that to a Z value. Now, the 85 is kind of a nice number. Why? Because what's the Z value going to be? If the mean is 100, it's exactly one standard deviation below the mean, isn't it? It's exactly 15 below the mean. So what's the Z value? 1? Careful.
-1.
Negative, oh, does that matter? Yeah.
Well,
Yeah, it's,
But I don't understand.
I don't either.
okay, well, what did we just do before we finished? You said whatever the value is, we need a Z value. Okay, well, if you have the mean and the standard deviation, that should be trivial. How do you find the Z? I'm not going to tell you the formula. Written it down, it's in your
Yes,
notes, it's in the
got it.
formula. What's the formula? What's the formula? Not what's the
It's
number.
Z equals
Oh.
X minus mu divided by standard deviation. Right?
So there's your X, there's your mu, there's your standard deviation. I mean, this is what we just spent the last hour doing.
I know.
We actually did this one. This was the first example I did, was actually in class, I did this one very specifically.
I just
Remember,
want
then
to,
we went to the whole Forrest Gump example. So,
Professor, I just want to know if I set it up right. That's all. That's all I'm asking.
exactly.
Okay.
So that's, by the way, it's very important. That's negative, isn't it?
Oh,
That's
okay.
important. 85 is below average. So
Oh,
it's
below,
negative.
below. Less than or below. Got it, got it.
We should teach, like, we should all take turns to teach a math lesson one day, because that is the best way to learn.
Yes, but only if you feel confident
Oh, yes, of
in
course.
the lesson, yeah.
But like, if we were reviewing for like a final exam, you know.
Well, actually, you know, that is it. Tomorrow when we review, if you remember what we did last time, I had you guys explain the answers. And I prefer
That's
doing it that way because if you're waiting for me to
That's
explain
true.
answers when you have a written answer
Uh-huh.
key in front of you, that's,
You're right.
what is the point of me explaining an answer when you have the key in front of you? That doesn't serve, you don't even need to show up for the review if that's what's going to take place. You already got the key. It's you explain, here's what we do, but here's why we do it. Because if you don't know the why, then how do you know you're going to get to the next one? So we know the formula for the Z calculation. It's score minus mean over standard deviation. But what do I then do with that value? Oh, the question was, what's the probability that I am below 85, which is the same as what's the probability that my Z is below -1? Now that should be a piece of cake. I'm not going to tell you until you know that. But that should be easy. You have a table right in front of you. Should it be a large, when it comes to probability, when we say large, we mean, you know, more than 0.5. That would be a large probability. Would this be large or would this be small? Yeah, because you're at the left tail, aren't you? You're left going more left. Yeah, so beautiful. And here's what I do. It gives me a visual. Does that correspond with that? Because the line is halfway. So you say, that's perfect. That's exactly what
I
I
was
want to
lost
do.
on this part.
We've been doing that the whole class. All right, the second question, now I have a betweener. So the second question is a betweener. How do I write the second question? What's the probability that X is between 100 and 125? So that means I have, and I like doing it this way. You can see exactly what we're doing. I have Z-scores. Well, I don't think you need a calculator for both of them. Why? What's the first Z-score? If the mean is 100, what's the Z-score that goes with a value of 100? You're the mean. You're right at the mean. Are you above or below the mean if you have 100? You are at the mean. So how many standard deviations above or below the mean are you if you scored 100? If you score the average, then you're 0, yes. If you score the average is a Z-score of 0. Because think about the picture, you're right smack dab in the middle. That's why I said you don't need a calculator for both of these. Do you agree that that one's pretty easy?
And then the other one,
The other one, use a calculator. 125 is a z-score. And by the way, it is okay to round because you're going to have an infinite decimal, but you can only look up 2 places. So you do have to round correctly.
1.7.
2 decimals. 2 decimals. Don't round to 1, because round to 2, because that's what your table is. Which one are No, 15 is the standard deviation.
Okay, so,
If you take the square root of variance,
okay.
this is standard deviation, that's easier. The variance would be the square, yeah.
Yeah.
Yeah, you make it harder than you have to. All right, so what is the z-score you get for the second one? 125 is what z-score?
1.67.
So it's 1.666666. Does everybody get that? You have to round it to 2 places, not 1, because your table has 2 places. So what would it be? 1.67?
Yeah.
So I like what Andrea did the first time. She drew a picture that corresponded with this. Would you agree that my picture should look something like that? Z-score of 0, z-score of 1.67.
The picture actually helps me,
It helps me.
but, I mean, it's extra, but it's still.
I find that, well, because the picture's simple, picture's not complicated, but drawing a picture that illustrates what you're being asked often really helps you make, it doesn't help you calculate the answer. It helps you make sense of the answer. Because if a z-score of 0 means you have the average exactly. Your 0 standard deviation is above or below, right? If you score the mean, then your numerator is mu minus mu. That's why it's 0. And I'm clearly on the right-hand side because the second score is above average. So is my answer going to be above or below 0.5 based on your little illustration? My answer is going to be above 0.5, so I've got more than half stated.
No.
Well, if 0.5 this way and there's 0.5 this way, and I want this much, is it going to be above or below 0.5?
Hello?
Yeah, it's going to be a lot below. I'm not using half of it. I'm using less than half of it. Again, what is the common error is to subtract backwards or to add inadvertently and then getting an impossible number.
Yeah.
Oh, I don't want to minimize that. Yes.
Okay, and the deviation or whatever would have a square on it. That's only time I would.
Variance.
Yeah, variance.
Yeah.
Okay, variance.
Now, we get back. Score minus mean. You're doing mean minus score. So that's 15 over 15. Is going to be 1. So you make sure you're using the parentheses. So you're entering the first one. It's 85 minus 100. So 85 minus 100. That's my numerator. Divided by 15. That's my denominator. That's what should be there. So then we do the same thing on the second one. Remember, it's score minus mean. So if the score is above the mean, then it's positive. If the score is below the mean, then it's negative. Now, range rule of thumb, got to be within 2 standard deviations. But if the mean is 100 and the standard deviation is 15, you can probably do that one in your head. Okay, now move on to the next cluster. Oops, why is this not moving? Oh, come on. Wow, it's frozen. There we go.
Yeah.
Now, the second one I really like. The second one, okay, if you buy an appliance, doesn't matter what it is, if you buy an appliance, you're usually guaranteed a certain amount of life before the thing dies, right? And you know if it dies early, no, that's not good. Sometimes you know you're gonna get a long life. But a lot of times you will buy an extended warranty.
Mhm.
And depending on the item you're buying, that can be a very wise decision. Because you don't want something to wear out prematurely and then buy again. How are warranties figured out? This is interesting.
Hmm.
This, by the way, the mathematics we're doing right now is exactly the mathematics of a warranty.
Hmm.
Think of it this way. You are, let's say you buy a dishwasher. We just bought a new dishwasher. You're expecting a few years of life out of the dishwasher, and it's really hard to abuse a dishwasher. So you're supposed to last you 5 years. You might get 6 years, you might get 7 years. Great. You got 3 years, you got 4 years, maybe. But what if your dishwasher only lasted 6 months or a year? You'd say, no, that's not good. So the manufacturer usually knows, and by the way, funny thing about appliances, the life expectancy of most appliances is normally distributed, strangely enough. So in this example here, they're saying, okay, this particular, the air conditioning unit, they found lasts 12.04 years. So that's a long time. We did a major remodel of my home in 2007, 15 years ago, and we had a huge air conditioning heat unit. It's still there, but we've had to add more. We're doing another remodel and we've now split it. But the original one it's tired. It was very expensive. It's tired. It probably needs to be replaced. And we've got 15 years out of it. So we've gotten tremendous life out of it. So let's say this particular air conditioning unit, they've sold thousands and thousands and thousands of them over the last, million years. They found that this is the mean and this is the standard deviation, and the life expectancy is essentially normally distributed. You're just as likely to have above as you are below, and so on and so on and so on. So what is the probability that if you buy one, you're going to have to replace it in less than 8 years? Now, less than 8 years, if it's supposed to last 12 years, it's probably not very good. So hopefully that's a small probability. Second question is, it's supposed to last 12. What's the probability you get between 13 and 17? So it means you're getting way above average. But then the bonus question, I'm not going to tell you how to do, but this is what warranties are for. Warranty is really for the ones that fail really prematurely. Now, by the way, the manufacturer usually has a warranty, their own warranty. They'll say a typical one will be 6 months. If it fails in the first 6 months, we're going to replace it because that means you bought a dud.
Yeah.
Okay. But let's say it only lasts a year or two and it's still a dud, but it wasn't dud enough. So you might buy the extended warranty that says, you know what? I'm going to buy the extended warranty that gives me another year or two over the manufacturer's warranty.
Okay.
You guys know what I'm talking about? Over that, because we did that, we have some LG washer and dryer. And the washer, I think, the dryer has like the washer has a 10-year warranty, the dryer had a 5. So we bought the extended warranty on the dryer. We haven't used it yet. It expires next month. We've already extended it, but we need to have somebody come out and look at it and start to make some noise. Those things are too expensive to replace.
Yes.
But I only had to pay like $60 for the extra year warranty as opposed to whatever, $1,000, whatever, something ridiculous.
Yeah.
Warranties is neither good nor bad. The company offers the warranty. They're going to make money in the long run because most people will never need it.
That's true.
It's basically the warranty is a version of life insurance. Think about that.
Yeah.
You're paying a small amount that you probably will never use or collect on. Now, you'll like this. Back in the day when, we all had VCRs. You guys remember those things?
Yes.
Your parents had VCRs. A wedding present we got, I was married in the horse and buggy days, but we got a really nice brand new VCR. Okay. And it lasted for a really long time. And after my first was born, it failed. And so it was still under warranty. We bought the extended warranty and we got it replaced. And then in a few months, it failed again, and then it failed again, and it failed again. We ended up, I think, getting at least 5. And they were taking them apart and go, God, the things that worked inside the thing they were breaking and bad things. And then after like the 5th one, they found a little small toy inside the VCR. And we finally figured out what happened. See, my youngest, she was probably maybe a year old, maybe not even a year old at the time. We'd popped the what would they call it?
I know what you mean. It's a little slot.
Not the DV, what the tapes? What are
Yeah. Not the DVD.
What are they, I don't even remember what they're called, the VCR, the video,
VHS, no, not
the
VHS.
VHS. We pop in the VHS tape. God, that's how long ago these
Yeah,
was.
I
We
know.
pop in the VHS and so my baby daughter saw that, so she'd take her toys and she would pop them into the thing. She was breaking all, because her hands were so small, that she'd pop it in and somehow grab things in there, or maybe trying to get her toy back. And we realized that they weren't failing, or maybe it was breaking them, but because we had purchased. And so after the last one, the place we got it from, they said, this is it. We're not replacing any, because they'd seen, we'd gotten maybe 6 of them in the course of like a year and a half. They said, that's it. We're not replacing any more. And I'm laughing because they lost a lot of money on us because of our extended warranty. Because my baby girl kept breaking them. But it's really funny that we realized that we saw her put her hand all the way in and grabbing the little controls. And see, you couldn't put your hand in there,
No.
but a baby could. She was very smart. So, I don't know what she was trying to do, take it apart.
Your kids sound really, really fast.
My gosh.
So anyway, yeah, this one, she's actually a chemist. So
Oh, my goodness.
Mason College graduate, by the way. So the last question is, I want to replace the worst 1%. Where would the worst 1% on the picture be? It'd be the furthest to the left. Does anybody understand that? The furthest to the bottom 1%, those would be the real lemons. And so any company that's any good is going to say, no, we're replacing that one, because you're not supposed to fail that fast. But I'm not telling you how long 1% is. You're going to work backwards and figure it out, because we've already done that, a version of that today. That's why it's a bonus question.
Well, actually, with Mensa, right?
I'm sorry.
We did that with Mensa.
Yes, we did that with Mensa. That was one of the many things we did. So the ability to say, here's a situation, what's the probability of this happening, just means I convert it to Z-scores. Piece of cake. If I said, I want the top 10% or the bottom 1% or the top 5, whatever, that's the one where we looked up the probability and worked backwards, like the Mensa example. You've seen every version of a question that can be asked. Now, I want to remind you, because there's no office hours today, because we're doing the review tomorrow, 11 to 1. It is necessary that you've done the practice test. Now, what I'm going to do this test, because I've got too much other stuff going on, you may redo the quizzes and things, or turn in ones that by the exam. But I would not wait until Monday night. That would be foolish, because you're not going to be ready for a Tuesday morning exam if you're still working on the previous stuff. So you really need to get that knocked out over the weekend at the latest. Now, if you got 20 out of 20 on a quiz, don't do it. Retake your quiz on your own to make sure you still know how to do the problems. It does, and I remind people, it makes no difference what you got on a quiz if you don't remember it for the test, because you don't get to bring that. So if you didn't turn one in, or you did lousy on one you want to redo, that's fine. Because I need you to know the questions, and the test will look just like the practice test, just like the last one did, because that's what we're doing. This is all material, obviously, for exam 3, which is a few weeks after we come back, kind of thing. Okay, now you all know that we have one more week and then we have a week off. You guys have been good soldiers, and so I'm going to give you a week off.
Well, thank
You don't have to come to school. And please don't come to school during that week, because you'll find your phone locked up and you'll feel really silly showing up. I laugh at this, but almost every year I'll have someone, oh, Mr. Brown, I came to school, the gates were locked and there was no one here. And it's like, why are you telling us this? You showed up, during spring break, or you showed up on a major holiday when everything was locked. The reason they do the lockdown, it's not for safety. Then they don't have to have as many staff, police and stuff on campus.
Oh.
If they make it so nobody can come on campus, then they can have a skeleton crew. It saves them money, in other words. And it drives me crazy when I try to come to campus, let's say on an odd time, and they've got in a lockdown prematurely. All right, guys.
Thank you.
Have a wonderful weekend.
Brother.
All right, you guys. And
Thank you.
remember, tomorrow, let me exit full screen. Tomorrow, we will be, go ahead and give me these back. Yeah, we will be doing the Zoom thing. I will send out a reminder, 11 to 1 review. Please make sure you have done the practice test. All right, guys, have a great weekend.
Quickly,